Hi everyone, we're going to verify trig identities with complex rationals, and this is part 2. In this case we have this little extra +1 attached, and usually when you have something like that, just keep carrying it down and don't deal with that until the very end. Obviously this is the more simple side, so we're going to deal with the more complex side over here. It's written in terms of sign, so I'm going to write these in terms of sign. And it's very similar to our part 1 we did, except we don't have this +1 thing. So just going to expand this by writing it as our trig ratios for tan and cotan. Now we're going to just keep carrying that 1. So basically I'm going to do just like I did in the previous video, and I'm going to write this with the common denominators cosine of theta times sine of theta, and then just cross up here. So we get sine squared theta minus cosine squared of theta. Alright, and then do the same thing for the denominator, and we get cosine theta, sine theta, and cross here, and you get sine squared theta plus cosine squared of theta. And then we have this attachment +1. So let's look at this. These two cancel, and this equals 1. So basically what we get is sine squared of theta minus cosine squared of theta over 1, so that leaves it, and then we still have our +1. So we need 2 sine of theta. So what I'm going to do is going to put this in parentheses, and when I do that I can write this as sine squared of theta minus cosine squared of theta minus 1. So after that I know that this is going to be and this should be a plus here, sorry. So anyway, when you do cosine 1 minus cosine squared, if I rewrite this, and put the minus back, if I rewrite this, I'm going to get sine squared theta plus 1 minus cosine squared theta. Now this equals sine squared theta. So, and I'll put it down in here, so we get sine squared theta plus sine squared theta, and there's 2 of them, which is what we have here. So we get 2 sine squared theta, which is the result we wanted. Okay, the next one's kind of similar with when it has this attachment to it. We have tan of theta minus cotan of theta over tan of theta plus cotan of theta. We want this to equal 1. So, oh, I forgot to add something. So this is plus, this is my little attachment here, equals 1. So I'm going to rewrite the left side here as sine of theta over cosine of theta. And I'm going to go a little faster because if I go too fast I make mistakes. So be careful. And write it again, but with a plus. Then we have this attachment here. Don't forget about him, like I almost did. All right, I can rewrite this with a common denominator, and we kind of been doing that. So that's going to be sine squared minus cosine squared of theta over cosine theta times sine of theta. And this part is going to be, I didn't leave enough room, so I'm going to just put it over here. So it's divided by that part. This part's going to be sinus squared theta plus cosine squared of theta over cosine theta, sine theta. And what happens is these two will cancel, because when you flip this, and this equals 1. So that cancels. And we're just left with this. I'm going to go ahead and write that on the next slide, and then we also are left with this. I'll go ahead and write it here. So we have sine squared theta minus cosine squared of theta plus 2 cosine squared of theta. Well, this part here is just negative 1 of these plus 2 of those. So that's going to be sine squared of theta plus cosine squared of theta. And that equals 1, which is our desired result. Okay. We have one more of these, so let's get to it. We have sine, or secant, theta plus tan. These are all very similar. And we have cotan of theta plus cosine of theta. And this is supposed to equal tan of theta, secant of theta. Now what I'm going to do is go ahead and write this in terms of sine and cosine. But I'm going to write it as 1 over, so this will be 1 over cosine of theta plus sine over cosine. Because when I do that, I'll have the same denominator. And then I have this one is going to be cosine of theta over sine of theta plus cosine of theta, and I'll go ahead and put that over 1. So let's figure out our common denominator is cosine of theta, which gives me, when you cross up here, you're going to get, since it's the same, well, you don't have to, it's the same denominator, so you just get 1 plus sine of theta. And then at the denominator, though, we do have sine is my common denominator. So you're going to get cosine of theta plus sine cosine of theta. Now, when you clean this up, we're going to go ahead and write this as 1 plus sine of theta over cosine of theta. And what I'm going to do, since this is division, I'm going to change this to multiply and flip this. So this is going to be sine of theta over cosine of theta plus sine of theta cosine of theta. Now, I'm going to go ahead and factor, and what I'm going to get is 1 plus sine of theta over cosine of theta times sine of theta, and I'm going to factor out the cosine. Cosine of theta times 1 plus sine of theta. So I just took the same thing, but I just dealt with this part here. Now, this part will cancel. So what we have is sine of theta over cosine of theta times cosine of theta, or 1 over cosine of theta. And I'm breaking it up. I'm forcing it to look like what we're supposed to have it look like. This is tan of theta, and this is secant of theta with your trig ratios. And that's our desired result. So basically, I went ahead and just multiplied this by 1. I put these two over each other, and I put this over that. Okay. Thank you. Have a nice day. The next set is similar. So if you need harder problems, we're going to get harder and harder here. Thank you, and have a nice day. Bye-bye.